So let's go to our third question on dimension analysis. So I like this question. It is interesting. Yes. So let's go to the question. So this question there states the displacement s of an object moving the straight line under uniform acceleration is given as the function of time t by the relation s is equal to ka m tn, so ka to the power m t to the power n, where k is a dimension constant and it goes on. M and n are powers of a and t are respective. Use dimension analysis to determine the values of m. So what should you do this? You know that s there, the displacement is categorized as what? S. That is the key. And also you know that acceleration is what? A. And t is time. Yes. How can you find those powers m and n? What should you do? So you rent this. So first thing you need to do, you need to categorize those. Start one by one. So we know displacement, which is s. So displacement is just the distance, and dimension analysis for distance is the range. Write like this. Write like this. Then also there is what we call acceleration. So acceleration, if you have forgotten acceleration, we said acceleration is meter per second squared. That is acceleration, meter per second squared. Now meter we know it is range. So range, write like this: dimension for acceleration, length, then over. So over, this is time. So time we write also t. T now is -2. That's what we write. The dimension analysis for acceleration, because if we say it's the same as m s to the power -2, because these two, remember in indices which we learned, these two, it means 1 over s. Yes. So that is the dimension analysis for acceleration. So you can watch our first video on dimension analysis. It has explained how you can put the units or the formulas into dimension analysis. So this is the displacement, which is s, and also t. So let's go to t. What is t? So t is equal to what? It's just time. So write t like that. That's all. Now, when you look at E, the question they ask us what? Find the value for m and t. In dimension analysis, we said what? K. This k is a constant. So in dimension analysis, we don't deal with constant. So constant we don't deal with that in dimension analysis. Yes. So any number, any constant, we don't deal with dimension analysis, because dimension analysis only deal with time, which is mass, and also range. That's all. That is the only thing which deals in dimension analysis. So if you have forgotten, try to refer to our first video on dimension analysis. So we don't deal with the constant. Now let's go on answering our question. So our formula is S is equal to Ka M then T N. That is our formula. Now, how can we express that in dimension analysis? So just write L, which is this displacement, it is range. So the dimension analysis for displacement, it is write it range. Then constant, we don't write it. Then we just write the dimension analysis for acceleration, which is L t to the power negative 2, because meter per second. Then also t, dimension analysis for t is just t like this. Then to the power n. So here to the power m. Yes. So we're just writing like that, nothing else. Then we repeat the same thing. Right, range is equal to this m multiplied by a, so it will be L m t negative 2m, like this. Then we have t to the power t n. We haven't done anything, we have just changed into dimension analysis. Now, when you reach here, you have answered the question. When you reach here, even the examiner, they will mark you that you have answered the question. Now, they want us to find m and n. So, n and m, how can we find it? In dimension analysis, we say what is on the left hand side should be equal what is on the right hand side. Principle of homogeneity. I explained that in the first video. So if you haven't watched our first video, I recommend you watching our first video on dimension analysis. So here we categorize the quantity. So we just categorize the length, time, and the time. That's all. So we do length itself. So we start with the length. So length, you categorize length. So here on the left hand side we just have length, one length, and then we just categorize only length. So here we just have one. How many lengths do we have here? We just have one. Also what? Length to the power m. Here this side we just have this length. That is the first. We categorize what is on the left hand side should be equal to what is on the right hand side. Yes. And also we move to another one. You categorize time. Do we have time here? We don't have time. So what should you do? Write t, dimensionize is t to the power 0. So is equal to, here we have t. So we have how many t? It is t to the power negative 2m, then t to the power n. So here this means you can write just like this because it's a multiplication here. This t times t. So it's the same as t negative 2m plus n. Yes. So t to the power 0 is equal to t minus 2m plus n. So if you have categorized this into different quantity like this, t with t, L with L, then you can find m and n. So what is our m now? So our m now. So what is our m now? So our m now, we say it is this raised to the power m. So raised to the power m. So here we know that when you look at what we are dealing with indices, so this can cancel, this can cancel. Here it's to the power 1. So m is equal to what? 1. So that is our m. Now we go to the t. So t, we said t, this side it was t to the power 0 is equal to t, which is n minus 2m. Yes, that's what we add. That side and this side, the dimension is for this side. Now, what should we do here? So here we'll do t to the power 0 is equal to t to the power n minus 2m. So what should we do here? T will cancel, t will cancel. So we are remaining with 0. 0 is equal to what? N minus 2m. That's what we are remaining with. because in indices we learned how we can calculate this. That was in grade 9, yes. So now we want to find what m. What should we do? So we correct this, select n is equal to m will go this side, so it will be 2m. Now remember, m we have calculated is what? M we have calculated is what? It is 1. So we have calculated m, it is 1. So we do n is equal to 2 times what? Times 1. So our n is equal to what? 2. So that is easy and simple. So final answer, we can say n, such that n is equal to 2 and m is equal to 1. That is the answer. That's what we find in dimensional. So dimensional analysis, any question they will ask you, it is simple and easy.